Okay, let's take a look at Newton's method. Okay, so the idea is that we want to find the square root of 3, which is 1.732050 something something. Okay, you can type this in the calculator to verify, right? It will be this value. Oh, so let's look at the method in general. If we have a graph and then we have y equal fx as the graph, the equation, we will have an x-intercept over here. This is a question mark. Okay, now let's start with our initial guess. This is x0, initial guess. Now we go up. We're going to hit the curve, we're going to have a point, x0, comma, this is a very funny notation, it's f of x0. So pretend if x0 is 4, then f of x0 means f of 4, which is really just, pretend that this is like, I don't know, x squared minus 3, then this will be 4 squared minus 3, which is just some number, 13, 4 comma 13, right? So this is just a notation for the y coordinate. You can call it y0, I don't call it y0, I call it f of x0. Repeat, so you start with initial guess, you go up, hit the graph, draw a what we call tangent line. Tangent line, the first tangent, you hit the x axis, which is the x-intercept, ding, like this, x number 1. With x1, you go up, you get another coordinates, which is x1, comma, f of x1. Okay, can x replace with x1. Then you draw a second tangent line, the red color tangent, it will ding, hit the x-axis again, the second x-intercept, which is x2. Oh, then what do you notice? Initial guess, x1, x2 is getting super close to the solution that we want, the question mark. So if we increase, repeatedly do the same procedure, go up, tangent, x-axis, go up, tangent, x-axis, we will eventually get to what we want over here. Okay, so let's do it with a concrete example. Let's say that we have square root 3, and we call x equals square root 3. We wish to find out the decimal value. How do you do that? We can square both sides, so x squared equal to 3. Subtract 3 on both sides, so x squared minus 3 equal to 0. Also, if we call fx equal to x squared minus 3, what we realize is that y equal fx, so y equal x squared minus 3. So this to that means that you're replacing the y with a 0. You're essentially finding the x-intercept of the graph x squared minus 3. So now let's draw x squared minus 3. We see that it's like this, x squared minus 3. Then there's an x-intercept here and there. Ignore the negative root, just focus on positive root first. We're going to start with an initial guess, let's say x0 equal to 4. Then we go up. This will hit the curve, so x equal to 4, then y equal to 4 squared minus 3. Okay, good. So that means that we'll have a tangent line. Then we wish to find the equation of this blue color tangent line, the first tangent line. It will hit the x-axis over here at x1, which is our first x-intercept. Let's do it. So, 4 comma 13. This is when x equal to 4, y equals to 4 squared minus 3. Because we have a x squared minus 3, we replace x with 4. So 4 comma 13 is the coordinate. Fx equals x squared minus 3, so f prime x equals to 2x. The x equal to 4, the y equals to 13. So if you sub x equal to 4, then f prime of 4 will be what? 2 times 4, which is 8. Then 8 is the gradient. Now, how do you find the equation of a straight line? It's y minus y coordinate equals to m times x minus x coordinate. So m is your gradient, x0 is your x coordinate, then f of x0 is your y coordinate. So that means it becomes y minus 13 equals to 8 times x minus 4. Yellow, then green, and blue. This is your equation of the blue color tangent line. Okay, then do we simplify it? No, we don't simplify it. Instead, you just move straight to your goal. The goal is to find x1, which is your x-intercept. X-intercept means that you have to sub in y equals 0. So we're going to sub y equals 0. Sub y equals 0, we get 0 minus 13 equals to this. 0 minus 13 is just negative 13. I'm going to do something clever. Over here, after I sub in y equal to 0 to find x-intercept, I solve for x minus 4. So times 8 bring over becomes divide by 8. Now notice that 0 minus 13, so there's always a minus sign here. Good. Then after that, minus 4 bring over become plus 4. So it's 4, then minus 13 over 8. Okay, good. Now we try to see, we label this as x1, because we know this is a very special x-intercept called x1. So we call it x, not just a normal x anymore, it's x1. Okay, then we color code this, yellow, blue, and green. Yellow minus blue over green. What is yellow, what's blue, what's green? Yellow is the x-intercept. Sorry, the x-coordinate of the point. We call it x0. Then 13 is the y-coordinate, which we obtain by substituting in the x over here with x0, where x0 is 4. So it's 4 squared minus 13. Then that's f of x0. Okay, good. Then the f prime, the green color 8 is really just f prime of 4. But 4 is x0, so it's f prime of x0. So we get a nice little formula here. Notice that everything on the right side is x0, x0, x0. Then the left hand side is x1. So the right hand side x0 converts into x1. Okay, the formula that helps us to convert from x0 to x1. Now we proceed, continue. We got our first tangent line, we got our first x-intercept. What do you do next? You go up again, you hit the curve at this point. How do you get this point? If you type in the calculator 4 minus 13/8, you get 2.375. So that's your x1. Then, if you have the x equal to 2.375, how do you find the y? You have to sub in into the formula here, y equal x squared minus 3, or f of x. So, you'll get a 2.460625. So this is x1, this is f of x1. Okay, good. Yeah, so now what we do next is we draw a tangent line. Tangent line. So repeat the procedure. Initial guess, go up, tangent line. Second, x-intercept, go up, tangent line. X-intercept, go up, tangent line, but we just stop at x2. So we're gonna now try to find the second tangent line, which is the red one. Then how do you find the equation of this second red color tangent line? What we do is, we let's list down the coordinates first. So x1 comma f of x1. So 2.375 comma 2.460625. Okay, good. Then fx equal x squared minus 3. F prime x is 2x. Then when x equal to x1 equals to 2.375, right? Remember now, the 2.375 is x1. Also, what happens is that we sub into our f prime x so that we can find the gradient of the tangent line. So f prime of x1 equals to f prime 2.375. 2 times 2.375 is 4.75. Okay, good. What do we have now? We have the x1, we have the y1, or f of x1, the coordinates of the blue color point here. We also have the gradient of the tangent line, the red color tangent line. You got point, you got tangent, so you can use a point. Gradient is also called slope, so we can use the point slope formula to find the equation of the red color tangent line. Y minus y coordinate equals to gradient multiply x minus the x coordinate. Okay, good. We have the equation of the red color tangent. What do we do next? We want to find the x2. x2 is the x-intercept, so that means that we have to sub y equal to 0. So we sub y equal to 0 directly. We get 0 minus this equals to this. Now what we do is we do a clever trick. We try to make this guy the subject. So times bring over becomes divide. So it's a negative 2.640625 over 4.75. The y coordinate over the gradient minus outside, because 0 minus, so it's always a minus. Then minus 2.375 bring over become plus, so it's positive 2.375 minus away y coordinate over gradient. What's 2.375? That's really just the x coordinate. This point here, yellow. The y coordinate, blue. The gradient here, green. Okay, so that means that we now have a solve for x, but I purposely put an index 2 here to remind me that it's the second x-intercept of the second red color tangent line. So now we have yellow minus, let me color code this, 2.640625 is the y coordinate, so that's the blue. 4.75 is the gradient of the tangent, and then in general we now have x2 equals to x1 minus away f of x1 over f prime x1. Y coordinate, x coordinate subtract away y coordinate divide by the gradient of the tangent will give you the second point x2. Then can you see a pattern between the two formulas? 0, 0, 0 turns into 1. 1, 1, 1 turns into 2. Can you see a pattern? Yes, in general it will be xn plus 1 equals to xn minus, always minus, f of xn over f prime xn. So n becomes n plus 1. Okay, we call this a recursive formula. Recursive means what? Means that the next term, the index n plus 1 term, depends on the previous term. Okay, then what we see here is that the initial guess is x0. You can this formula, you replace n with 0, you'll get 0 plus 1, which is 1. So you get x1. Now you can update the n replace with 1, 1, 1, so n plus 1 will now become a 2. So from x1 turn into x2. Now you replace n with 2, 2, 2, you get 2 plus 1, which is a 3. So from x2 you can turn into x3. and then x4, and then x5, and then x6 all the way. It will usually get closer and closer towards the actual root you want. Also, now let's see how can we, oh by the way, if you type this in, you get approximately, not equal, approximately 1.81907, I think so. Sorry, excuse me. Then for now let's carry on. What we want to do is to use the ANS. How do you use ANS to help us to get all this decimal? Wow, I don't want to type so much, right? I want to just get the answer, then how? If I don't need the working. Is there a way? Yes, there's a way. How do you get this 2.375? How do you get this 1.81907? Let's do the following experiment. We're gonna type in square root 3. Let's recall the value. Okay, good. Then I type in 4. I type in equal. I press clear. For my calculator, I need to press clear. Most calculators don't need. Okay, next, what we do is we press ANS minus fraction ANS square minus 3 divided by 2 times ANS. So now, how where did this come from? It came from the recursive formula here. You see, the xn is ANS. F of xn, recall that fx was x squared minus 3. So xn is ANS. So this is ANS square minus 3. Oops, where's the working? It's over here. Oh, then how about f prime of xn? It means this guy, but you replace the ANS, sorry, the x with xn, and then xn with ANS. So in other words, the x replaced with ANS. X replaced with ANS. So 2 times ANS. Okay, then you also realize that, hey, it's just 2.375. That's the value that we got just now. Okay, good. So x1 is 2.375. You started with x0, which is the ANS 4. ANS was 4. Then when you type this in the calculator, you will replace it. Well, the calculator will automatically replace the ANS with the previous value 4. Okay. Now how do you get the x to 1.8190789? Look, observe what happens. I press equal. I press clear. Then now I press. Don't press on. You press up to recycle the same answer. I press left. Then it will display the editing mode. If I press equal again, what happens is the ANS will get updated with the previous answer, which is 2.375. How you get updated with x1? I press equal, what happens? Hey, isn't that this value? 1.81907. Oh, if you're not convinced, you can manually go and type this into your own calculator. You should get the same answer, 1.81907. Because essentially what we're doing is we're replacing the x0 with x1. Oh, the ANS gets updated with the previous one. Then how about x3? Very simple, just press equal again. Then I copy down the decimal, 1.73, 413260207. How about x4? I press equal again. Then I get 4.73, 205205715. How about x5? I press equal again. 1.73, 205080757. How about x6? I press, since we're already here, let's go for x6. Let's press equal again. Equal. Nothing happened. Did I misclick? No. Because we have reached the limitations of the calculator. They cannot get any closer. The decimals are hidden at the back, I guess. It appears the same because we have reached the limit. We can't really continue already. The calculator no more memory space to go and calculate this, or maybe it doesn't have enough space to display all the decimals. Oh, then let's quickly press clear, and then we type square root 3. What do you see? It's the same. Oh, so therefore we have created a formula that helps us to calculate square root 3. Okay, that's how we use ANS.